Okay. All right, folks. Thanks for coming out to the October event for the Atlanta Kubernetes Meetup. As I always say, whatever the digital equivalent is of coming out to a meetup these days, we appreciate you doing it. First thing we like to do is to open up the floor for anybody who is hiring in the community. So anything that is kind of Kubernetes, cloud native related, go ahead and drop information in the chat, and I will read that out loud after we do the news. Make sure you include contact information for a point of contact in the company. And what I'll do is I'll make sure that that's included in the show notes that we post after every event. And you can also, after the event, if you're seeing this on YouTube, feel free to also go PR into our GitHub repo at KatesATL. You can do a PR into the show notes, and we'll merge that so you can have people who are hiring there as well if you happen to miss the event itself. With that, I will go ahead and hand it off over to Mr. Joe Searcy for the news.
All right, thanks, Alex. Give me a second. Let me get my screen shared here. All right, so a lot of stuff going on in the Kubernetes community over the past month, at least more than we had last month going on. So we're still in the 1.20 Kubernetes release cycle. We've had a couple of dates slide a little bit, especially with the 1.20 beta 0 that was scheduled for October 27th. That I haven't seen a message come out that that's been done yet, so I think that's pushed back a little bit. But we're still on target for December 8th for the release, currently tracking 55 different enhancements, and there is a link to a tool that you can use to look up and see what all of those enhancements are that are tracking for this release that I'll link to later. I didn't have time to add that in here. We are past the enhancements freeze, but there is a deadline for November 2nd for any exceptions that you need to file. So if you're currently working on anything, get all that buttoned up with your documentation and everything else. Also noted, there were fixed releases for the currently supported upstream versions of Kubernetes. So 119.3, 118.10, 117.3. I have a link in the doc here for the details on that. A couple of different security related things in there, and then some general upkeep items. So if you have the ability, go ahead and get updated to those versions to have the latest and greatest. PRs of note, there's a lot of stuff going on, a lot of different moving parts, but a lot of it's kind of supporting work going on in the Kubernetes project. So only a couple things that I wanted to call out here. One is the dual stack nodes PR got merged. This was a huge effort. I want to say this was something like 11,000 lines of code changed to get this going. And so this essentially is supplying the base for being able to provide dual stack as far as IPv4, IPv6 at the Kubernetes node layer that will eventually trickle up and play into how services automatically get created within the Kubernetes service registry and things of that nature. So lots of good information here. Go and check that out. Another thing to note on this is the kind of community teamwork that's going into this is pretty awesome. As far as the level of collaboration and communication, again, this is an extremely complex thing to change. This is low level, so it kind of affects a lot of people using Kubernetes, and they're doing it in a really transparent manner to where if you don't need a dual stack environment, you'll probably not notice it. But the PR review alone is kind of a crazy process too for something this large. So interesting to take a look at, really cool example of how the community comes together to move things forward. The other thing is, and this was a change related to the fixed releases that came out, and this was masking bearer tokens that were being logged in different places as the log level was increased. So again, just something to be wary of if you do have any clusters where you're running like a high log level or something like that for debugging or troubleshooting, or maybe that's just where you run it at normally. Just know that there is a potential for bearer tokens to be logged at that level. So especially if you're distributing your logs out to something else like a Splunk or with Fluentd to Elastic or something like that, just be wary that you might be shipping that stuff around where people could view it. So be mindful. The other thing is the Kubernetes Steering Committee elections completed. We have the results. Huge shout out to Dims, Jordan, and Bob, longtime contributors in the Kubernetes community. Great folks that are always out there and available to help you. So nice to see them leading the technical direction of the project. Try to remember what this is. Oh, so out on the Kubernetes developer mailing list, there's some discussion that's starting around the Kubernetes release cadence and what that looks like going forward. So if you have any opinions on how frequently Kubernetes releases drop, how long, if you have a preference on how many you'd like to see per year, how frequently you'd like to see those drop, or how infrequently, make sure you jump in there and voice your opinions. In the realm of the CNCF kind of project acceptance graduation, shout out to Rook, who has graduated. Rook is a Kubernetes persistent storage provider with a CSI driver model. It uses an opinionated configuration of Ceph under the covers, I believe. Really cool project. Good to see more projects go through this graduation criteria. And somewhat, hopefully spoiler alerts here. I know OPA is currently going through the voting process with the Technical Oversight Committee for graduation too. So good luck on that, Torin and team. KubeCon North America 2020. This is a virtual event, but the schedule has been posted there. If it's something that you're interested in, go and sign up. As per usual, same thing with the KubeCon EU. All of the session videos will be posted after the fact. So if you want to save a little bit on money and you're not worried about getting the info now versus later, you can always go that route as well. And then into the interesting projects list. There were so many that I saw over the last month and that people posted here and there. So it was hard to narrow it down to just a handful. But I tried to put it into two categories that I've seen be a big anthem throughout the Kubernetes community so far this year. And that is around kind of fleet management and how you manage things across multiple Kubernetes clusters, as well as some things around Kubernetes security that's kind of just an ongoing item. So Admiralty was the first one that came up. And this is a pretty interesting project. I tease Alex from time to time because he wrote a pretty sophisticated CD system in his last company that's very similar to this. And I always bugged him about open sourcing it. But so essentially, Admiralty is a system that defines some primitives on how you can do multi-cluster software deployments with Kubernetes. So it gives you the framework to define what your deployments look like, what your lifecycle environments and your overall deployment topology looks like, and then kind of automate your deployments from there. So it's pretty cool. They've got their documentation and stuff up. The project seems to be pretty active. So interesting thing to take a look at if that's something that you're looking at right now. Next up is Cron. So this is a similar concept. It takes a slightly different approach to it. So what was cool here, and I've seen a couple different products that are doing something similar, but this is how you kind of layer on all of the components that you add on top of Kubernetes. So, your GKEs and EKSs and stuff like that are essentially push button, give me a Kubernetes cluster. But then you need to layer the stuff on there like ingress and, storage providers, logging, monitoring, service mesh, policy as code tooling and stuff like that. So this defines a kind of abstraction layer of how you can build out what those things look like and deploy them in a consistent fashion. So another thing that's pretty cool, really nice to see lots of different fresh ideas in this space. Because I think as people mature in their Kubernetes adoption, once you get past probably about 10 clusters, you start to run into problems with how you do these things. Another one, so this is from a Kubernetes security focused company called Alcide. Um, and this is a kind of standalone tool for doing Kubernetes image scanning. And there's a lot
So
of stuff out in
really
this.
quickly, can you command plus your text there a couple times, where we just have a request in chat to increase size?
Um, so there's lots of tools out there, and many of them come integrated into these like big enterprise products that have lots of moving parts and things like that. So sometimes you just want to be able to do stuff kind of ad hoc, or you want to integrate it into your already opinionated system that you've built out internally at your business. So this is kind of a cool thing here. It plugs into a couple different like container registry systems, as well as it looks like it has a pluggable model for discovering vulnerability information or whatnot. But pretty interesting little tool. And then last but certainly not least is a tool called Tracy. And this is from the folks over at Aqua Security. And back to our conversation on eBPF, this is not necessarily relegated to only Kubernetes, but it's a container packaged solution for systems event tracing using eBPF. So really, really cool here. You can deploy this on like standalone, pretty much, any Linux type systems out there. It can also be packaged up and run as a privileged container to where you can grab tracing information for system calls and things of that nature at the host wide level. And then it also adds some configuration to scope things. One of the things that this tool does, just from like reading through and playing around with a little bit, that I thought was pretty unique, is the fact that you can set it up to only capture things after it's deployed. So you don't get a lot of noise like before the event that you're trying to monitor for or something like that. So pretty cool that it has that type of filtration capabilities and whatnot. And that wraps up this month in Kubernetes. I will turn it back over to you, Alex.
Awesome. Yeah, Joe mentioned we were talking about eBPF earlier. eBPF Summit's actually going on right now. It's the first day was today, and it's also going tomorrow. Liz Rice from Aqua Security had a great talk today and mentioned Tracy. Very interesting tool, worth checking out. Okay, so I actually did not see any hiring announcements in the chat for this month. So I guess we are very quickly going to move on to our content for this month. Our first talk today is from my esteemed co-host here, Mr. Joe Searcy. The topic for the meetup today is really Open Policy Agent, or OPA, you're gonna hear everybody call it. It's run pretty heavily at T-Mobile, where Joe is a member of technical staff, and he is gonna be talking about how OPA is used at T-Mobile.
Give me just a second. All right. All right. Let me know if everybody can see the screen. Okay. All right. Sweet. So again, hopefully everybody knows me by now. Is probably tired of listening to me talk month after month. But my name's Joe Searcy, and I am a member of technical staff at T-Mobile. And we started our journey with Open Policy Agent probably about 2 years ago at this point. And we've had it deployed in production pretty much across our entire fleet of Kubernetes for the better part of a year and a half or so now. But before we dive into a lot of the specifics on that, let's kind of start with a really basic high-level overview of what OPA is. And again, OPA stands for Open Policy Agent. And OPA is a tool that provides a generic interface to implement policy in a declarative way that has some pretty unique feature sets here. And so this slide is a little busy here. It shows a lot of stuff, and that's kind of on purpose. It's really hard to condense everything about OPA into like, one slide, but I don't want to steal Torin's thunder because I'm sure he's going to talk about some great stuff later on. But the point that I want to get across here, those 3 bullet points, it's general purpose. So this isn't specifically tied to Kubernetes, and I want to make that pretty clear. But while it does have a lot of application around Kubernetes, this can be used and is meant to be used kind of across anything out there. The other thing is everybody usually scoffs at like, oh, yet another like, tool specific language that I have to go out and learn and do this, that, or the other. So part of the reason why I'm a really big OPA advocate is I started out building some tooling for policy as code on Kubernetes, implementing my own policy framework and policy engine. And my biggest recommendation to you is don't do it. It's a lot of work. And when you start getting down into like the really fine-grained policy implementations, you figure out really quick where the power of the regular language that OPA uses comes into play. And the other thing here is it's declarative. So as you've spent all this time kind of wrapping your head around like Kubernetes' declarative nature and whatnot, this plays really well into that. And policies that you think would be really complex to write start to get very simple. And again, I'll leave that for Torin to go into super detail on later. And then the data-driven for like contextual policies. This is something that's super important, and this is something that's really kind of hard to implement on your own in a scalable fashion. But OPA has a really strong kind of data API where you can bring in context from lots of other different types of systems, whether that's like identity information, information that maps users to groups or anything like that. Or it could be information that's generated during the time of like people interacting with your systems or services and whatnot. So it can provide for like dynamic policies and things like that, where the context changes, but the rules in your policy don't need to change necessarily. So really cool stuff. And then again, back to the point of like OPA kind of works with, most things. Just a super small clip shot, and I kind of just got tired of like copying and pasting logos from the OPA website of all the different companies and tools that they integrate with. But wanted to throw some big ones on here to kind of show you the breadth just in this small sample here. Hopefully a lot of these icons are pretty recognizable to folks, but anything from your traditional Linux systems and integrating at the points of things like SSH and whatnot to your CI/CD systems, to security tools like Sysdig, API gateways like Glue and whatnot. Envoy is a big one, but lots and lots of different integration points here. One of the other things that I want to call out here is it's pretty flexible in the deployment model. It can be deployed as a daemon that kind of runs alongside, anything else, whether you think about that as a literal daemon running on like a Linux system, or as a sidecar to a different container. It's also, if you write your applications and services in Golang, you can use it as an embedded library. And then it's also flexible to where it can be used in a Kubernetes context as like an admission controller, and I'll talk a little bit more about that later. So now that we've kind of covered what OPA is at a super high level, talk about like how we came to use it at T-Mobile. And I told you a little bit about the story, but background on that is as we got into Kubernetes, we realized very quickly that it was going to be something popular. The adoption rate internally was going to be very high, as it solved lots of problems for our development customers internally at T-Mobile. So that happened, and we went from this like really, really one-on-one white glove treatment of every new development team that onboarded, where we sat down with them and we talked through what their application environment looked like, what their stack was, and how it might look as they transition from what it is today to what it could be on Kubernetes. And we were very, very successful in that. But as the number of development teams, the number of applications, the complexity of applications increased, our support team for Kubernetes did not increase at the same rate. So it was pretty obvious early on that we needed to take all of the best practice configurations and opinions that we had developed around that and security and things of that nature, and we needed to produce some tooling that would implement those in a programmatic fashion and allow us to take and scale those as our adoption rate scaled internally. And so that led us to this Kubernetes policy as code concept. And that was really, again, I started out building the tool from scratch, built my own policy framework and policy engine. It worked really, really well, but it's a lot of upkeep. And as we needed more and more kind of complexity in the types of policies that we wanted to enforce, the work kept growing with that too. And I came across Open Policy Agent and started playing around with it. And I was like, wow, like I can take policies that were written in like dozens of lines of code and drop them down into like 5 or 6 lines of code. It was pretty cool in that. And I was able to literally overnight take all of our existing policies and transition them to OPA, and have this out in like a working model. And that's how I met Torin. And, we've been working together to kind of polish some of this stuff over time and build our internal know-how around OPA and Rego since then. And that has led us to look at other ways to use Open Policy Agent. And so I'm not going to talk through all of these in detail, but I wanted to put some bullet points here just to kind of show you like the pure range. Think outside the box of like, yes, we can solve the Kubernetes problem, check, but also a lot of other problems. So the generic human to service and service to service authorization, everybody, and their brother and sister out there has some type of authorization model. And when you get a really heterogeneous application and software landscape, each tool and each vendor and each thing has its own opinionated way that it handles that. So being able to use something like OPA that provides us a generic interface for that, we can start to build like common RBAC and auth-z across all of our tooling, to where we not only simplify like the number of things that engineers and developers have to worry about learning and whatnot, but we start to really build our institutional knowledge on this tooling specifically, and it becomes kind of commonplace across everything. Same thing, so like enforcement of IAM policy standards. So again, at a certain scale, having like a team gate developers by saying, oh, let me create that policy for you, let me create this resource for you. Even if it's in a like infrastructure as code type perspective, you still have that people gate in there. And so that's something that we wanted to remove. And part of what we did is we just said, you can kind of bring your own IAM policy. And we have a specific set of OPA policies that go through and verify that people don't do something crazy like allow star and stuff like that on an S3 bucket or something of that nature. So that took, again, just another piece that we took our opinions, put them in Rego, and use OPA to like enforce those and kind of keep things between the ditches. We also were very GitOps driven in a lot of what we do and how we build the products that we offer like as a company. And we have a very rich CI/CD solution for like corporate delivery. And as part of that, a lot of those things are driven via like JSON or YAML type configuration that lives out in the Git repository somewhere. And so again, through the goal of empowering our development teams to take us out of the path of them getting stuff done, we're able to build policies that do sanity checks and things of that nature, that make sure that they're going through and doing all of the static code analysis and doing things with signing software the right way and all this stuff. We're able to enforce that again, using OPA and Rego for the policy there. One of the other interesting things, and this was something that was kind of out of the blue and somewhat lazy to some degree. So I'm not necessarily advocating everybody go out and do this, but it was like a quick turnaround for a really cool thing. But OPA has a couple different components. So there's like the core OPA policy engine, data API and stuff, but then there's a little side project called Kube Management that essentially is this thing that can scrape resources in your Kubernetes cluster and shove them into OPA's data API automatically. And so we had this project where like everybody can like log into a Kubernetes cluster and do kubectl git, deployments, kubectl git pods and stuff like that. But again, once you get to a certain scale, say you have 100 different Kubernetes clusters and you want to be able to like know, well, what are my pods across all 100 of those clusters, you start looking at things like API federation and stuff like that. And so since Kube Management and OPA already had this model where they could just scrape all the resources on a cluster, put them into a programmatically accessible like API, we were able to really quickly turn around this cool platform API. And I'll talk a little bit more about that in a second. But so it doesn't stop there. Kind of once we got into this mindset of like, I hate to say like we found a tool and we're looking for problems to solve, but it is a pretty ubiquitous tool that has allowed us to solve many problems. And we've started thinking in terms that anytime with any new project that comes along, if we get to the point of thinking about policy or anything like that, we kind of say, how can we use Open Policy Agent for this? And so some of our future use cases are around some of the newer functionality that's available with OPA. Again, I'm not going to go into much detail on that. But using things with like Envoy and Service Mesh and API gateways and different things of that nature, along with the capabilities and portability that you get with something like WebAssembly, it unlocks a lot of really powerful features that we're pretty excited about where that space in general is going. And we're going to keep an eye on that as it relates to those technologies, plus you integrating them with OPA. And then the last thing there that is something we have in flight is this kind of enterprise-wide application report card tool. So the concept of a Kubernetes admission controller has been out there. It's really great for like stopping things at deployment time. But what about like after deployment time and different things of that nature? And we really wanted to decouple this from security necessarily, because we want like rich security tools up front and shifted left as far as possible to catch things before they ever even get to the cluster. But one of the things is a lot of the Kubernetes admission controller concept is like scoped to a single Kubernetes cluster. And so we want to start building policies that like really stretch the entire fleet of clusters. And we want to be able to look at what an application team or development team deploys and say, like, do they have things deployed across multiple regions? That's a policy we build and can check. And again, through OPA and its data API, we can take all of that contextual information, put it into OPA, and then run policies against it. And these really complex assessments of like, are they doing the right things, get merged down from like, hours or days into seconds to be able to process that information. So lots of really cool potential there. But one of the things that I've spent a lot of time personally working on is the policy as code for Kubernetes piece. And again, I started out doing my own thing, found OPA, and kind of revamped the project to use OPA. And then I was lucky enough to get the approval through the company to open source this project, kind of as a means to show people, this is how far you can go and some of the things that you can do with OPA while wrapping kind of customized business logic around OPA itself. And so MagTape or Magenta Tape is the project that came about. And this is a Kubernetes validating admission controller. It gets deployed and each pod has 3 containers that it runs. There's the MagTape application itself, OPA as a sidecar, as well as Kube Management as a sidecar. And again, the Kube Management piece allows us to cache the resources across the Kubernetes cluster and develop policies that are scoped beyond the request object that comes into the Kubernetes API. We can also look kind of cluster wide and bring in the rest of the contextual data from the other resources on the cluster. And all of this is driven to give feedback to the user in at a simplistic form and allow deny concept, though we do get a little bit more complex to that and have some different types of passive alerts and failures and things of that nature. And then is anything really a thing if you don't get Slack alerts and metrics out of it these days? So we of course have Slack alerts that come out, and we have some Grafana dashboards that allow us to track metrics. I'll talk a little bit more about that. So I mentioned Slack alerts. This is one example of Slack alerts that MagTape can generate here. So in a quick snapshot, this tells us that this was an actual policy denial, meaning that something was blocked. And that's where you see like the red coloring there. And we see fail high for privileged security context pod found. And then we see some other entries there for things like liveness probes, readiness probes, resource limits, so on and so forth. So this details exactly what policies were violated and kind of the severity associated with each of those policies. If you look closely as well, at the end of each one of those lines, there's an MT or a MagTape code And what that is it's a number that you can go like to the repo and look up and get even more detail about what that policy is, kind of what causes a failure, what the bounds are, and what is expected. So we can keep these messages really, really short, but still give people a way to kind of self-service look up what they mean for more information. And then also you get details about what cluster it was, what namespace, what the deny level is set for the cluster, what user sent the request, what workload it's associated with, so on and so forth. So enough context to kind of, as an administrator or as a developer, to know like where to look and what to look for. On the flip side, I mentioned these kind of passive type alerts. So with each policy, we have the ability to define a severity level for that policy. Some things like a privileged pod, we want to block on, but a missing liveness probe or missing resource request, maybe we don't want to block on that, but we still want to get alerts. So MagTape provides this kind of hierarchical mechanism to where you can define which deny levels and severity levels send what type of alerts if stuff gets blocked or if it doesn't. But this is an example of a passive alert. So this was a policy that failed, but it didn't block anything. And again, you get the same type of contextual message here. All of this information gets fed back if you're doing something interactively with like kubectl, like it gets fed back at the CLI as well. I'll kind of show you that in a second. With some of the new features in Kubernetes 1.19, we can now provide feedback for admission responses that aren't a deny, which is really cool. Pretty excited to have that in finally. And then I mentioned metrics, and this is sort of hard to read at this scale, so don't worry about like looking at it. Just know that this exists and it says stuff. But this is a breakdown of like each row here represents a specific policy, and then it gets broken down in the kind of columns of blue, green, and red. Blue is just a total count, and then the green and red break down into pass and fail for the policies. And so this is a way for us to kind of see like what specific policies are teams like struggling with more than others, or do we see? And it allows us to focus on like where we drive education to our development teams as far as teaching them and helping them learn about the features of Kubernetes and what good configurations look like. We also have other dashboards that break that down by namespace so that we can see like, hey, we need to reach out to team X and really talk to them about liveness probes. They're struggling with that. We see a lot of failures on that. Or we can see that, hey, the privileged pod alerts are going like increasing at a rapid rate from this namespace. Something is awry. Let's go see what's going on. And it could be something as simple as they just copied and pasted, a Helm chart off the internet and tried to deploy it. And, or it could be, something malicious going on. So really, really nice to have the metrics to kind of drive that stuff. And then again, when we talk about policies and whatnot, this is just kind of a snapshot of different policies that we have out in the MagTape project by default. Again, it consumes Rego. It's plain Jane vanilla OPA under the covers. There's some specific formatting expected in the Rego policies, but outside of that, sky's the limit. So again, checking for things like liveness probe, readiness probe, if the blocking host port, host path, being able to lock down like the node port range is a good policy there, where you annotate a team's namespace with the specific node ports that they're assigned. If they try to deploy services that use different node ports, they'll be blocked. Different things like that. And even the Istio project always provides some type of fun for new problems that pop up here and there. And so a while back, there was an issue if you deployed a service that referenced a logical name of like HTTPS, but the port was 80. Istio would kind of crap the bed, and services across the entire cluster would go down. So it was really nice to have this tool out there on all of our Kubernetes clusters. I wrote this policy literally in like 5 seconds because it was kind of copy and paste from something that we already had and changed a couple things. Deployed it out there, and we were immediately like protected against that type of thing. So really cool functionality there. Not going to go into a bunch of detail here, but this is just kind of like a high level logical diagram of that platform API that I mentioned. where we have OPA deployed on every cluster that's scraping all of the resources on that cluster and exposing them via an API. We have a little auth proxy that we run as a sidecar, so that it's like uses our standard enterprise authentication methodology. And then we have an aggregation layer that takes that from all the different clusters that we have and puts it in one place. And then we can like list all the clusters that we have from an API. We can list all the namespaces across all the clusters from an API. Same thing with, you know, pretty much any of the Kubernetes resources. But what this does is, first it was sort of kind of a science project of like, can we do this really quickly for this like one really specific thing? But it's turned into, we have a lot of CLIs and tooling that we're developing that consume this. If you want to iterate something, like do something that and iterate over every cluster that we have, we now have a consumable API that we can just get and loop through and do whatever. It's super handy to have. And then the generic auth-z model, not too dissimilar, but as we have all these different platforms and you know, touch points between, from like service mesh to Kubernetes ingress to service mesh sidecars to Cloud Foundry to Envoy directly, and then any standalone application, we were able to build this kind of authentication and authorization proxy that uses OPA for all of the auth-z, the authorization piece. So we can bring in the contextual authorization data and have that available to the API. So if you need to build some type of RBAC into an application that runs on any platform, you can now essentially plug into this auth proxy, and it just works. It doesn't matter what language you're using. It doesn't matter if it runs on Windows or Linux or anything like that. It just works. So pretty cool feature here as well. And so that being said, I'm just going to do a quick sort of demo on MagTape to show you a couple of things here. Give me 1 second. And I did not have as much time to prepare for this as I would normally like. So here's hoping the demo gods are in my favor today.
Real quick question, Joe. George Castro asks, how many pods in a cluster? I'm guessing average.
For MagTape or for in general?
Why don't you answer both? He didn't specify.
Yeah. If it's for MagTape, I think the default like quick preview install is 3. But it can be 1, it can be many, it scales, it does leader election, it does all that stuff. And so let me see, I can't actually remember what state we left things in here. So I don't have anything out there, and I'm just gonna quickly do make install. And this is like a single line install. You can go out to the repo, literally copy 1 line and just kubectl apply it. It installs everything. The MagTape pods, they have an init container that handles the generation and rotation of the certificate bits that are required for secure authentication or secure transmission between the Kubernetes API server and the validating mission webhook and MagTape. So all that stuff's kind of handled for you. And if we do a look and get, if I spelled that correctly, we've got 3 pods running out there, and then I've got a test namespace set up out here, and this is another thing. So you can kind of enable this on a per namespace basis just by setting this label on the namespace set to enable. Once that's done, MagTape will start paying attention to the things that happen in that namespace. And it can be as simple as tell that to go into the right namespace though. You can see here that we get a message back from the Kubernetes API server that says the admission webhook magtape.webhook.ktmobile.com denied the request. And we see that same information that you get in the Slack alerts gets printed out here too. And then let me see if I have the new kubectl installed on here, which I think I do. Ooh. All right. So in Kubernetes 1.19, I might not have deployed the right version of Kubernetes in my kind cluster. It gives you the ability to print back warning messages to the end user. So those same messages that you see in the Slack alerts, and then right here, you can also get back in a better formatted method. And also for the passive alerts on things, you can get those messages printed out here, whereas previously, before Kubernetes 1.19, if the admission controller didn't completely block a request, you got no feedback at the command line whatsoever. And then going into Slack here again, you can see that, you know, this generates the passive alerts in amber and then the active denials in red here. And then in addition to getting alerts for kind of the platform administration side of things, end users can annotate their namespace and with a Slack incoming webhook URL that points to one of their Slack channels, and they can receive the alerts in their own Slack channel scope to messages for their namespace only. That being said, that's the end of my session. Any other questions from the chat or anything?
Nothing currently. We can give a few seconds to see if anybody wants to post anything. You can use the Q&A feature or just dump them in chat, folks, and I'll read them out. Looks like Eldon has something he's typing out. Also, for the people on panelists, feel free to unmute yourself and just ask your question out loud.
I'm watching with debate at Eldon's question. Still think.
Well, I have a question before Eldon gets his together.
Sure.
How does the routing work for this? So something gets applied, the admission webhook controller sees it. How does that routing work? Does like the admission controller sheet, does it route it to the leader of the magtape pod, and then how does that route back?
So in this case, magtape is the admission controller. So there's a configuration that gets applied to register an admission controller with the Kubernetes API. It used to be just two forms. I think there's now a third form of that, but there's the validating admission webhook, which I think the resource is called validating webhook configuration. There's a mutating webhook configuration, and I think now there's an authentication webhook configuration. But so magtape uses a validating webhook configuration, and that defines the information to tell the Kubernetes API server, I want to watch for this type of resources in like this Kubernetes group version, you know, API. I want to watch in this type of namespace or in this specific namespace, or you can say, I want to watch in any namespace that has a particular label or doesn't have a particular label. Magtape uses the label selector there. And then you define some kind of cryptographic bits that like a certificate bundle that allows the API to talk to the magtape admission webhook in a secure manner. So when the request comes in the Kubernetes API, based on that validating webhook configuration, it says, does this resource fall under this, what's defined here? Does this namespace that the request was sent to like have this particular label? If so, forward it to the endpoint on the magtape pods. And magtape, the Kubernetes API expects a specifically formatted admission response message. And that has a handful of fields that are like allow or deny, you know, and things of that nature.
Gotcha. Follow-up question: where do the other external requests happen? like Slack, this is your admission controller. How does it also post to other HTTP endpoints?
Yeah, so it's just, it's Python code on the covers, so it's just calling the Slack APIs and the metrics. It's just instrumented to do to produce the Prometheus like compliant metrics on /metrics endpoint. And so like the metrics piece is kind of up to you. I provide some example dashboards, but to have Prometheus configured to scrape that endpoint and the Grafana set up to connect to Prometheus, that's outside the scope of what we have documented in the MagTape project itself. But I think pretty standard for most shops running Kubernetes these days.
That's super cool. Thank you.
Yeah, I did actually I finally got my question together. So when you're like trying to do potentially like Flex CD, what is the feedback in that process look like? Is that something y'all have worked with? Like, I say I merge my thing to Git, what does that look like?
Yeah, so like the admission controller is somewhat indiscriminate of like the user or the account that like produces, or how the request for that matter like makes it to the Kubernetes API. So again, whether you're doing like a raw kubectl apply of YAML, whether you've got some Golang app using client Go, or you've got a Helm chart or like whatever, it doesn't really matter. As long as it's compliant with the Kubernetes API, it flows through the admission response queue, so to say. So in CI systems, CI/CD systems, you get the same feedback, right? So as long as you're capturing the response back from Kubernetes and however you're deploying, mechanizing your deployment within CI/CD, like that should be output in the logs for that particular task or job in your CI system. So it could easily be instrumented to like do additional API calls, like instead of like just calling Slack or whatever. It's not pluggable for that right now, but that is something that you could. Again, that falls into the case of business logic, which is kind of what the whole MagTape experiment is like take the things that are important to your business and wrap it around OPA and like make it do the thing. So yeah. And yeah, if that's something you'd like to see in MagTape, feel free to open up an issue on the repo.
PR is welcome. Huh? The other
go ahead.
Was, hold on just a second. Up past our bedtime. The other question I had was around timeouts. So anything at scale, or like you're building this system, like it needs to be resilient. Have y'all developed any kind of best practices around timeouts for OPA or MagTape?
Absolutely. So all of the like API calls internally, and that is like even though OPA is running like as a sidecar, like MagTape calls OPA's API on like local hosts, right? So all of the internal API calls have a timeout set, and the default response is a deny, and that's something like it's configurable, and in our case we decided that from a risk perspective, if the calls to OPA didn't succeed, or if the Kubernetes API calls to the admission controller itself don't succeed, we want that to fail closed. But you can, that is 100% like you can toggle that. If you want it to fail open, you can do that too.
Cool, thanks.
So there's a question in Q&A from our buddy Bailey. He asks, how would you use OPA with Flatpak or Snapd? So it sounds like package managers or other kinds of Linux containers. I guess maybe either Torin or Joe.
Yeah, I'll defer to Torin on that. I'm not sure if you cover things like specifically around that in your talk, Torin, or if you
I don't get into like the packaging of OPA so much, and I'm not super familiar. Like I know what Snap is. I'm not sure what Flatpak is, but maybe I'll just give an answer, and then if it's not good enough, we can follow up later. So I guess what I would say is that like OPA is pretty lightweight. It's implemented in Go, and it has like no external dependencies. So we actually build like a statically linked executable. So it doesn't even depend on like libc or anything like that. The Docker image that we ship is just from scratch. So it's about as lightweight as it can get. So in terms of like packaging it into something like Snap or something else, I don't know how much work that would be, but hopefully it wouldn't be too bad. I do know that folks have created like their own packagings of OPA. So like Brew, there's a community managed like Brew install of OPA. That's not like the OPA maintainers don't handle that. That was just organically created by the community. There was like a Chef Habitat one as well that got created. We have folks asking periodically for like an ARM64 build, which we can't support right now because we don't have the infrastructure for that to test on.
There's our RPM and Deb, like that you guys support.
Yeah, so I guess the just short answer is that if we don't support it today, it's a great thing for the community to contribute, and we try to make the project as lightweight, like the actual executable for the project as lightweight and easy to run as possible.
There's a new Docker build option that lets you output to compile on different, architectures. So that's pretty cool. But yeah, I mean, it's kind of that's very cool. I didn't know that you all were thinking about that. It's awesome.
Cool. All right. So I'm going to wrap up the Q&A for my talk there. If you have any other questions, like further questions, feel free to reach out in the chat, or we can talk afterwards. But I specifically wanted to talk first in this because I did not want to follow Torin here. But Torin is a longtime friend. I've gotten to know him pretty well through our OPA journey at T-Mobile. Learned a ton from him. But to more formally introduce Torin here, he is the co-founder of the Open Policy Agent Project and VP of Open Source at Styra. Yeah. All right, cool. And he's been active as a software engineer for quite a time in like large scale distributed system type projects and whatnot. If you look at any of the KubeCon videos around Kubernetes policy and Open Policy Agent, you'll see him out there. You'll see him across speaker, all of the different slide deck hosting sites out there and whatnot. But welcome, Torin. Glad to have you. And that being said, turn it over to you and hear some more about OPA.
All right, sounds good. Let me just share my screen here. I did a live stream the other day, and I thought I was sharing my screen, but I wasn't for like 5 minutes. No one told me. So I'm going to ask.
That happened once or twice, yes.
I'm going to ask.
You can see your screen.
All right. Thanks, Joe. Yeah, so my name's Torin. I'm one of the co-creators of OPA. I work at a company called Styra. We are the kind of creators of OPA. We started the project a little while ago. That's my Twitter handle if you want to get in touch with me after this. That's my GitHub handle. It's the same handle on the OPA Slack as well. I'm super happy to be here. We were planning to do this meetup back in March or April, I can't remember, and then something happened and it got postponed by a little while. So I'm glad to finally be here with you all. So I thought what I'd do today is just kind of give a kind of an intro to OPA, just for folks that aren't familiar with it. So I'll go through a little bit of the background. I'll give kind of an overview of how it works, what features it ships with. Then I'll do a little demo. I'll show you kind of how you can interact with it, how you can get started with it. And then I'm going to talk a little bit about some of the more recent features that have gone in and stuff that we're working on that I'm personally pretty excited about. Like I said, we started the project at Styra early 2016, so almost 5 years ago now. And the goal since the very beginning of the project has basically been to provide a building block that allows you to unify policy enforcement across a wide range of different software. And so after we got the project kind of like off the ground and the initial kind of implementation was done, we went out and we started looking for different use cases where it could be applied. And lo and behold, there's lots of folks with all kinds of different policy enforcement use cases out there, right? So we see OPA today widely used for all kinds of different things like admission control in Kubernetes, where you want to put down guardrails on Kubernetes clusters. or just generally like cloud platforms. So all kinds of companies like T-Mobile, Capital One, Goldman Sachs, as well as cloud providers like Google and Microsoft have kind of like used OPA and jumped on OPA and used it, shown how you can use it to control fine-grained access inside of Kubernetes. But then it's also widely used for API authorization use cases, like establishing role-based access control rules for microservice fleets. And so one of the early users of the project was Netflix. We did talk with them a long time ago. They basically use OPA to control access to a large kind of heterogeneous fleet of microservices. So those are the two big use cases, but there is this like constant kind of like long tail of other applications that we see for it. There are lots of folks that are looking at it for things like risk management, data protection, data filtering. We see people using it even at the host level for controlling SSH and sudo access, driving IP table provisioning, all kinds of different stuff. The project itself is hosted by the Cloud Native Computing Foundation. We're currently at the incubating stage, like Joe mentioned. It's currently we're going through the process to become graduated, so that's exciting. And then we track lots of metrics for the project. So there's lots of folks contributing. There's a Slack organization which I'll link to at the end. That's got like 3,000 people on it. So if you want to get started, kind of with discussions or Q&A, that's a great place to start. Like Joe mentioned, there are over 30. I think I measured it before. There's like 40 different integrations that we have on our website. We're always looking for new integrations. The project's pretty widely used. So why did we start the project kind of in the first place, right? And I think if you just kind of step back a little bit and you kind of look at how we build and operate or deploy and operate and manage software today, things have changed a lot over the last 10 years, right? We've kind of moved away from like simple 3-tier apps running on a single server, or a set of well-known servers, managed by a specific team to more powerful systems, right? But more complicated systems at the same time, right? So we've taken kind of like monolithic applications and we've broken them down into microservices, and we spread them across clusters. They get like dynamically scheduled and scaled, and they're managed by different teams, right? So we've got different people now that have their hands on the deployment configurations. We've got different teams that are building services in different languages, right? They're making different choices about like what databases they're going to use, what CI/CD systems they're going to use, right? So there's been this Cambrian explosion of choices out there for software developers and for platform teams, right? And so the part of the challenge around that, when it comes to things like security and more generally just policy, is that typically the way you would manage rules or guardrails in these systems would be handled differently in each and every one of these different projects or products, right? So Kubernetes would have its own way of doing policy. Envoy would have another. Kafka would have another. Your CI/CD systems would have yet another way, right? And so that fragmentation ultimately results in a system that's really, really hard to manage, right? Because in order to understand the overall kind of security posture or policies that are governing the system, you have to go into each and every one of those different subsystems and understand how they let you express policy, like how you actually write the policies that matter, and how you get them enforced, right? And then at the same time, you've got this shift, like I said, to systems that are much more kind of dynamic, right? You no longer just have applications that are deployed onto a static set of servers and then get kind of like left to run forever, right? So you can't just easily draw like a network boundary around them anymore. And that wouldn't even work because everything's over HTTPS anyway, right? So what good are your network policies at that point? You need to have kind of like finer grained policies that follow the application around and can apply to the actual application APIs, right? So these challenges around like diversity and dynamism really necessitate a more kind of modern approach. And so that's what OPA provides. So OPA basically exists to unify policy enforcement across a stack by providing a building block that you can take and kind of plug into any piece of software at any layer in any system, right? So these are all examples of systems where people have taken OPA and that are run it in production for all kinds of different use cases. So whether you're talking about enforcing guardrails like inside of a CI/CD pipeline or inside of your container orchestrator, or whether you're talking about enforcing microservice API authorization policies or access control over Kafka, OPA provides kind of a single way to think about policy and rules and enforcement. And by the way, if there are any questions, like while I'm going through this, I'm happy to kind of just interrupt and answer them. I want to make this like as interactive as possible. So feel free to jump in if you've got questions. So this is a diagram that we kind of use all the time to just explain what OPA is. It really kind of like distills it down to its essence. And so what we, OPA or Open Policy Agent, or OPA as we like to call it, is basically a general purpose policy engine. What that means is that it allows you to offload policy decision making from policy enforcement, right? So that's kind of the core thing you're doing when you use OPA, is you're decoupling the enforcement of policy from the decision making around policy, right? So, like, just as an example, if you were building a service that served salary data on employees, right, it would expose an API that allow you to look up the employee's salary, right? So you'd be able to do like get/salary/Bob to look up Bob's salary. And inside that request, you'd supply like your token or your authentication information, right? And so when that request comes into the service, it needs to make a decision about whether you are allowed to see Bob's salary, right? So if Alice is like looking up Bob's salary, the service needs to decide whether or not Alice should be allowed to see that data, right? That's a policy decision at the end of the day. And it might be based on a whole bunch of different factors, right? It might be dependent on what device she's connected, from, where she's connecting from, who Bob is, who she is, what the relationship is in the organization, right? There's all kinds of different data that'll kind of drive that decision making. And so the way that works with OPA is that when the service needs to make a decision about that API request or any kind of decision, it'll execute a policy query against OPA. So it'll ask OPA with an RPC call, basically, whether or not that API call should be allowed. And when it makes that query, what it does is it sends a bunch of data across the wire. So it'll send basically a bunch of attributes that describe the incoming API request. So things like the method and the path and the headers and the token and all that information that describes the API request. And then OPA will take that data and basically evaluate it against rules, policies that it's been loaded with, as well as extra contextual data, like Joe mentioned, to produce a decision that it'll send back to the service to be enforced. One of the important design decisions that we made very, very early on in the project was that it wasn't going to be coupled to any project or domain specific data model. So OPA itself is not coupled to Kubernetes or Envoy or Kafka or any of these kind of like logos you see here, right? All OPA sees coming in is JSON data, right? It doesn't know the meaning of that JSON data. And when it's evaluating the policies, it just sees it JSON being evaluated. And similarly, the decisions that get generated by OPA can also be arbitrary JSON values, right? So you can generate like true or false to represent allowed and I. You can generate a set of strings to represent reasons why the person's being denied, like Joe showed. It can be even a complex like structured object, right? So OPA itself is completely decoupled from the domain. Now the policies you write, those obviously understand the data that's coming in. They have domain knowledge about Kubernetes or microservice APIs and so on, but OPA on its own is decoupled. Were there any questions? I saw something pop up. I wasn't sure if that was a question.
Yeah, there is one question, Torin. This is from Shahar. Is it possible to feed OPA dynamic policies and use it as a rules engine?
It is, yeah. One way to think of OPA is as sort of as a rule engine. And one of the ways that, one of the nice things that OPA provides is the ability to just kind of reload policies on the fly, like doing hot reloads. So you can basically update the policies without any impact to performance. So I'll talk a little bit more about that in a minute. And I'll also talk about how different ways that you can use it, because we do see people using it for all kinds of different use cases. And the fact that you can embed it really easily makes it useful as a rules engine for sure. All right, so what does OPA actually give you, concretely, right? So the core thing that OPA provides, and I'll show some examples of this in a minute. One of the core things that it provides is a high-level declarative language that we call Rego for authoring policies. So Rego basically is purpose-built for OPA. And it's purpose-built for allowing you to write down rules that answer questions like these on here, right? Is this a user allowed to perform this operation on this resource, right? Or like what invariance would this workload violate if it were to be deployed, right? Like if you're talking about Kubernetes, right, you might want to put all kinds of checks in place to prevent bad things from happening in your cluster, right? Like Joe did, right? So you want to be able to say, don't run container images from registries outside the company. Don't allow workloads to be deployed if they don't have, CPU and memory limits. Don't allow workloads to be deployed if they don't have readiness and liveness probes, right? Don't allow, developers to spin up public load balancers, right? There's just this huge long tail of different kinds of rules or invariants or guardrails that you want to put in place when you're operating systems like Kubernetes. It's not just Kubernetes though, it's also other systems like Terraform and so on, right? And so OPA provides you with a language that's sort of purpose built for writing down those rules over arbitrary structured data, right? So you can basically load in arbitrary JSON or YAML data into OPA and then have these rules expressed against it that produce kind of different kinds of decisions. So the language is really, really good at helping you write these rules, and it has a bunch of features that make it easy to write policy. So we've got what we call a library of built-in functions. These are just functions you can call inside of your policies that are useful when you're thinking about authorization and admission control and other kinds of use cases like that. So we've got a whole family of functions for working with JSON web tokens, right? Because those are just kind of prevalent and pervasive when it comes to API authentication today, right? So you can basically load in raw encoded JSON tokens into OPA, and then kind of decode them, verify the signatures, extract the claims, use the claims to make all kinds of decisions and so on. We've got functions for date and time. So we have users that validate contractual obligations, for example, right? Using OPA. There's all kinds of functions for things like CIDR arithmetic, right? You might want to we have users that verify like large numbers of firewall rules using OPA policies, right? And so being able to check whether or not an IP address is contained within a CIDR block that's considered safe or not is super important. So that built-in function library is super important. The policies that you write, or one of the features that OPA's had since the very beginning, is this kind of context awareness capability. And so what that means is you can basically load in external data and have it cached inside of the policy engine in memory, and then you can reference that data inside of your policies. So this is going back to what Joe was talking about. Like in Kubernetes, a lot of the policies you want to write need extra information about the state of the cluster than just the current resource that's being admitted into the cluster. So like when you create a deployment, you might want to look up information that's stored on the namespace that deployment's being created in, right? There might be an annotation or a label on that namespace that you want to use in the decision-making process. Or I'll show an example later, but like if you're looking at resources like ingresses, you might not want to allow conflicting ingresses to be created, right? So there's this like kind of general problem with networking and ingresses where if you have two ingresses in different namespaces, let's say, that claim the same host name or the same path, depending on the ingress controller, you can get traffic steered to the wrong place, right? And that's not a fault necessarily of the underlying networking technology, it's just the way networks work, right? So being able to basically see an incoming ingress resource and scan the state of the cluster, to scan all the other ingresses in the cluster in order to detect a conflict is absolutely key, right? So this ability to load in arbitrary contextual information and use it in decision making is super, super important. We see it used widely outside of Kubernetes as well. People load all kinds of data from systems like Active Directory, internal entitlement systems are really popular at like financial services companies. Also like inventory systems, right? Lots of large organizations build out inventory systems, and so being able to reference that data when you're making decisions is just kind of table stakes.
Sort of a layup question because I already know the answer, but I think it's important for other people. How does that data model work? Is it push? Is it pull? Like what kind of circumstances are supported there?
That's a good question. I wasn't going to go to that level of detail, but yeah, so we try to make OPA as flexible as possible. So we actually support both push and pull models, and you can also push and pull synchronously and asynchronously. Okay, so you can load data in asynchronously, like you can push data in asynchronously, so it's just cached in memory and it's just sitting there. You can have OPA configured to periodically pull in data asynchronously. But you can also push it. You can also push it in synchronously, like with the policy query, and you can have the policy reach out on the fly and fetch data. So we basically cover every possible way you could imagine getting data into the engine with different mechanisms. So there's a page on the website, which I'll just jump to. Why not? So if you go to the website and you go to the documentation, there's a page down here on the left called external data, and this goes into the different options about how you can load different kinds of data into OPA and when it's appropriate to use one over the other. And so, yeah, if you're interested in this kind of thing, definitely check out this page. It's a really useful resource, and it gets into the different kind of performance and availability trade-offs associated with different options. So, Thank you for that layout, Joe. Other language features that it includes are the ability to write policies that are composed of sub-policies, and to be able to delegate policy decision making to other policies. So, a lot of the time, or all of the time, essentially, policies are not they're not owned by like one single group, right? There's different stakeholders, right? So you might have folks from the platform team, you might have folks from InfoSec, you might have folks from the networking team, right? And they all need to be able to kind of contribute to the overall policy. And so OPA has built-in features that allow you to delegate the authoring of policies to different groups within an organization, and then go and compose those different policies and the decisions that they generate into a final decision that gets generated for your software. And then obviously to deal with different conflicts that can arise when you do that. If you said, policy A allows and policy B denies, well, that's a conflict. How do you deal with that? The language kind of guides you and helps you do that. And then lastly, the language is declarative. So there is a learning curve with it. It's not, if you're used to like Python or JavaScript or just a standard kind of imperative language, there is a little bit of a learning curve there. I like to say that it's steep but short. So like there's an initial kind of what the heck's going on, but then once you get it, you've got it. And it's done. It's a very simple language at the end of the day. And one of the things that makes it so simple is that you don't have to worry about all the kinds of things that you worry about when you're writing, Java code or Python code or whatever, right? You don't have to worry about like things like error handling, or like whether you use a map or a list, or whether you use a hash table or a tree, right? That's just all handled for you, right? And so because we handle that for you, it affords us the ability to implement various performance optimizations. So we try to, as much as possible, take on the burden of global performance optimization for users, so that policy authors can just look at like the PDF or the wiki where their policies used to live, and they can just take them and plonk them down into Rego kind of word for word as they existed on the wiki, without thinking about, different low-level implementation details of that we're all used to when we program. So we have all kinds of powerful performance optimizations like rule indexing and partial evaluation. I'm not going to go into too much detail there, but just thought I'd mention that. In terms of like what you actually use when you get the software, like Joe mentioned, you can take it and you can run it as a daemon. You can also just embed it as a library in Go. So the project itself is written in Go. We try to keep it as lightweight as possible, like I mentioned earlier. So it is easily embeddable. Regardless of whether you're running it as a daemon or you're running it as you're using it as a library, though, we tend to think of it in sort of exactly the same way. And the way that I think of it is that it's a host local daemon or a host local cache for policy decision making, right? So the idea with OPA is that you take it and you run it as close to the software needing decisions as possible. So like in the context of Kubernetes, for admission control, it's typically just running on the same cluster, right? So that when the API server needs to get a decision, it doesn't have to go off cluster to get that. It can just ask the local component. Some people take it and they run it on the same API server, or on the same host that the API server process itself is running on. But it's always running on the same cluster. When you're talking about microservices, though, it's a lot more sensitive, right? If you imagine like a typical application that gets broken down into like a set of microservices, you can't have each one of those microservices calling out across the network every single time it has to make a decision, right? You'll kill yourself for performance because now you're paying that network latency on every hop. And you'll kill yourself in terms of availability as well, because now if the network gets slow or it's down or the host that OPA is running on fails, your application's not going to be able to get a policy decision. It's going to have to fail close, because we're talking about whether Bob can, or whether Alice can see Bob's salary. We don't want to fail open on that. So so the way that we think about OPA is that it's this kind of host local cache for decision making that enables a distributed policy enforcement model. So to do that, certain decisions we made early on were like the policy and data were going to be stored in memory. So it doesn't require you to deploy any kind of like database or anything like that in order to store the policies and data the data that it's evaluating. It's just all stored in memory, which makes it super lightweight. And it also means that there aren't any kind of decision time dependencies, right? So when you ask OPA for a decision, all the decision making happens locally in memory. So it's super fast and it's not subject to like network latency or network downtime. Obviously, if you go and you take your policy and you make it pull data on the fly, then you have to think about that. But on its own, it won't do that. So that's sort of the core engine and the language. Now, if you think about it, right, if you've got these OPAs running throughout your infrastructure on every cluster, or next to every microservice as a sidecar, and they're all storing policy and data in memory, the question becomes, well, how do you manage that, right? You can't you can't just have them all storing data in memory and have them go down and not be able to, make decisions. So how do you manage that? And so OPA has a set of what we call management APIs for controlling and observing the engines. So the management APIs are what you kind of use to push down policy and data to the engine and collect telemetry back. So for example, there's what we call the bundle API, which is used for distributing policy and data down to the agents. I'll talk a little bit more about that later. There's the status API for receiving updates from OPA that tell you what version of the policy, what version of the bundle is loaded in the engine at this point in time. There's a decision log API, which allows you to get an audit log of all the policy decisions that are being made by OPA as it's running. So every time OPA makes a decision, it keeps a little record of that in memory. And inside the record, it not only knows that it made a decision, but it also records the actual data that was used to make that decision. And then it can either send that to console, so you can have it teed off to a different logging system, or you can have it batch them and upload them via HTTP. And so that basically gives you the ability to build out like an audit log of all the decisions with the inputs that were provided to the policy and the version of the policy, which opens up all kinds of interesting use cases around testing and debugging and auditing. And then there's also a discovery API for dynamically configuring the agent, right? So you can dynamically configure the agent in terms of like what policies it pulls down, where it gets them from, and so on. So I'll show that bundle service API in a second here. The last thing I'll mention is that OPA embodies this idea of policy as code. It has since day one. And so it comes with a pretty complete tool chain to help you build, test, debug, and debug your policy. So there's a command line tool you can use as an interactive shell. It comes with a test framework, so you can write unit tests for your policies. This is like a really, really simple idea. Like, we do this for a code, wouldn't we do this for rules and policies that govern, how people can use the system, right? It's kind of really simple, but
I'll jump in right there and say, if you decide to go down the path of like integrating OPA as like a core thing to your stack, start by writing your unit tests and your policies like ASAP. Don't wait and go back and do it.
Yeah, we've embraced this idea of like test-driven development. And once you like learn how to do it, it's really, really powerful because of the way the language works, the way OPA works. It makes it really, really easy to write those tests, and you just gain tons of confidence. There's one user that was basically helping a hedge fund in London get Kubernetes deployed, and this was like in air-gapped networks. So that he was going to basically like ship them a bunch of configs and binaries, and then hope that it just like came up. And if he had to debug it, he was going to have to like it was like yeah. So he used OPA, like he had a whole bunch of policies he had to put in place, and so he used the test framework. He got them all kind of like. He had 100% coverage. He was super confident. He shipped it. It all just worked on day one. He was like super happy with it. He said it was a complete game changer for him, because if he'd gone off and done something else, he was sure that would have been problems. So highly recommend the test framework. And then there's tooling to kind of like format, do kind of different semantic checks, analyze the policies, and so on. We also have IDE extensions. So there's a VS Code extension today that's been widely used. So if you're a VS Code user like I am, you can just go to the VS Code marketplace, search for Open Policy Agent, and install it. It has a bunch of nice features, like it lets you do testing. It also lets you do some other stuff that I'll show in a minute. And then the project also has more advanced kind of tooling called like tracing, so you can understand exactly why policy decisions were made the way they were, tooling for profiling, benchmarking of your policies, and so on. And then the last thing here is the playground. And so I wanted to kind of switch over now and just kind of show how you can get started with OPA if you're new to the project. So if you come into the website, you can obviously go to the documentation. But what I like to do is just go to the playground, because this is an online environment where you can kind of get started playing around with policies and kind of interacting with them and understanding how they work. So I think it's like super useful as a tool to get started with. So right away when you come in here, you just there's a hello world policy that's installed in here by default. If you click evaluate on the top right, what happens is that OPA on the back end will go off and evaluate the policy, and it'll print the result. And so in this case, it's telling us that hello is true. And so the reason why hello is true is because OPA evaluated these rules here. So there's one rule called hello here at the default with a default value of false. And then the second rule here is basically what's causing it to be true. And so basically, like it's evaluated the policy with this input data, and it's produced this output. So the way that you can kind of understand this rule is essentially it's an if-then statement. So it says hello is true if input.message is equal to world, right? So it's like the simplest possible thing you could imagine. Otherwise, hello is false. So that's just like the.
Can you increase your font size?
Oh yeah, absolutely.
Perfect. Yeah.
Better. So this is just like a little hello world example. What I can do is kind of like walk through a little bit more, slightly more complicated. So like if you imagine that policy that I talked about before, right, where we have a service that's exposing an API that serves salary data. The input to OPA might look something like this, right? It might have like a method that indicates, in this case, it's a get, so it's a lookup, and then a path, looking up, say, the salary for a user called Bob. And then there's a user, let's say, that's making a request, and that might be Alice, right? And so what we want to do is put some rules in place that would govern access to this, right? And so the convention usually with API authorization policies in OPA is to just create rules called allow. There's nothing built into OPA called allow. That's just a variable inside the policy, and we're just happening to assign false to it by default. It doesn't mean anything to OPA. So that's just sort of a convention. So we'll say by default allow is false. Otherwise, we'll say allow equals true if the input method matches get and so say the policy we want to put in place were to say users can look up their own salary, right? So we want Bob to be able to look up his own salary, but Alice shouldn't be able to see it necessarily, right? So change that to Bob. And so what we'd want to do here is basically match on the path and the user. And so you can do that inside the policy simply by saying path equals salary user. I've injected a variable into this now, so it's going to match that string Bob, and then we're going to check if the user equals that variable. Okay, so I've just put a simple rule in place now. When I evaluate the policy, it's true, allow is true. If I change this to Alice, let's say, it's now false, right? Because she's not asking for her own salary. So this is just a simple example, but it's kind of useful. One thing I'll just point out here is that you don't have to say equals true everywhere. If you leave that out, it's just implied. So this means exactly the same thing. One of the nice things about the playground, though, is that you can evaluate arbitrary parts of the policy. So when I'm clicking evaluate here, it's evaluating all the rules inside this policy. And so right now we only have one, but if I added another, like let's say I said is read method, and I move this line down. So it means the same thing, but now when I evaluate the policy, I get back two answers, right? I get back allow and is read method. So that's cool. I can see everything, but sometimes I don't want to see everything. Sometimes I only want to see, the value of is read method. And so if I just select that and I click evaluate, it tells me just the value of that one rule. Or if I click allow, it'll tell me just the value of that. Right, so you can actually select arbitrary portions of the policy, not just these rule heads. You can also select the rule bodies, right? So if I say is read method, it's true. I can also select multiple statements inside the policy, right? So if I click that, now it's evaluating just that selection, and it's telling me telling me the answer to this selection is basically that user is Bob. So it's telling me the value of that variable. Now if I go select the rest of the rule, it says no results found. There's no results found because user is Bob, but input user does not equal Bob, right? So that's false. If I go change this to Alice and I evaluate, then of course it'll pass. So the playground's a really, really useful way to kind of get started experimenting with policies. We have a bunch of different examples built into the playground. So if you're looking at OPA for different use cases around like API authorization, some of the access control use cases are useful. This is more like application level. So if you're looking at building out like IAM inside of an application, those are good examples. We have a bunch of examples around Envoy as well. So for example, this is an example that shows how you can do JOT decoding and verification with Envoy. So in this case, the data that you see on the right-hand side is a little bit more complicated now, right? It's this kind of like deeply nested JSON data structure that Envoy sends to OPA whenever it asks for authorization decisions, and it's got all kinds of information in it, like the source and destination IP addresses, all of the HTTP headers, you know, and all that information and so on. But then that information is made use of inside of the policy here. So what this is basically saying is that, again, by default, allow is false. Otherwise, allow is true if is post is true and is dogs and claims.username equals Alice. So this, just to understand this, basically it's an and, it's a logical and within this, within each rule body. And so in these different rules, we're kind of digging into this JSON data. And again, you can just select it and evaluate it and see the values. It's super helpful from a debugging point of view. But then you can do obviously more than just simple kind of equality statements. Like in this case, the input data contains a bearer token, right? So it's just passed the JSON headers across to OPA from Envoy in this case. And so there's a bearer token there that's a jot. And so what we want to be able to do is like look up the claims inside that jot in order to make a policy decision. And so to do that, we're gonna first we'll verify the signature on the token. So we're happening to use a symmetric algorithm here. You can do asymmetric as well, but we're verifying the signature on the jot, and then we're decoding the jot and pulling out the different parts of it using another built-in function in the language. And then above here, we reuse that value that we computed below for our policy. So like if I evaluate this policy, obviously there's a bunch of other rules defined inside this file, and so they all show up here. So that's an Envoy example. We've got a couple others that show how you can work with Envoy, and then there's a bunch of Kubernetes ones as well. So this is like a simple example of an admission control policy for Kubernetes. Typically for admission control, you don't want to like whitelist every possible thing that's allowed in the cluster, because it would just be insane, right? If you imagine deciding for every single YAML field and every single YAML file that you deploy whether it's allowed or not, that would be crazy, right? And so instead you kind of flip it around and you establish like blacklists or deny lists, I should say. And so the pattern here typically is that people will write these deny statements that basically construct a set of reasons why the resource, the Kubernetes resource, shouldn't be allowed. And so like in this case, we have a single deny rule that's basically saying that all container images must come from a certain registry, right? And so this rule is basically matching on the type of the resource. In this case, we're only looking at pods. We could generalize it to other types of resources as well. But then it's basically iterating over all the images in the pod and then checking if the image in the container or from the container is not starting with the right prefix, right? And so again, just another example of how flexible OPA is, right? You can use it for all these different kinds of use cases. One other thing I wanted to kind of show just before I talk about what else is coming is some stuff we worked on, we added earlier this year that I think is pretty cool. So I can just take this policy and if I click publish here, we give you a nice shareable link that you can take, you can copy. If you file bug reports against OPA, these are super helpful. Put the policy in the playground, share it, put it on Slack, put it in an issue. But also if you want to just try it out, try this policy out locally with OPA running on your machine, you can do that. So there's links here to download the latest version of OPA and get it on your system. Once you have it on your system, though, you can just copy this line and run it. So, okay, can you guys see my terminal here?
Yes.
All right, sorry, my home directory is disgusting. So let me just close that. So if I just run this,
I'm sure Joe's is worse, Torin.
Every now and then I gotta go delete all those x.yaml and x.json files over there. So I just ran this. What it's doing is it's basically it's running OPA. Maybe just to start, you can just OPA run on the command line. When you do that, it drops you into a REPL where you can do simple things like run expressions and ask is right, and so on. That's just a simple kind of REPL read eval print loop experience that you get. You can query for different data that's loaded into the engine by default, like the version and so on. So that's just what happens when you OPA run. If you OPA run --server or --s, it starts OPA in server mode. And when OPA is in server mode, it just serves an HTTP API that you can use to query it for policy decisions. And so that's all that's happening here really, is we're running OPA as a server, we're setting the log format, we're enabling decision logs, which I'll just show in a second, and then we're telling it to download the policy bundle from the playground. So we've shared the policy in the playground, and now we're going to run with it. And so if I do that, OPA is running. You can see that it downloaded the bundle and successfully activated it. And now I can basically I can query OPA locally and see what it returns. So if I take this input value from the playground, and I will have to drop it into a text editor here. Oops, that's not what we want to see. So I take that. I can now query OPA with this input. And so in order to do that, we just have to wrap it simply like this. So now we get the same decision back that we got from the playground, right? So you can interact with the API on the command line, obviously. You can ask for the specific, all decisions in this case, or you can ask for specific ones. You can ask for the Kubernetes validating. If you make a deny decision, it'll just return that one. When I run these queries, OPA logs the decision to console because I've got the console decision logger enabled. So you can see here that it's logging this off. It has all the input data that was supplied, labels of the OPA, all that good information, performance metrics, and so on. So if you're looking to get started with OPA, obviously read the docs, but then go try something out, right? Take a use case that you have and try it out in the playground. It's a great way to get started. All of this functionality you see here in the playground, like this interactive evaluation and so on, is all available inside VS Code. So it's not like you're locked into the playground or anything like that. It's all supported in standard IDEs. So that was it for the demo. I think we've got about 20 minutes left. I just wanted to cover a couple new things that are coming along down the pipe that I think are pretty cool. And so one of them is just around the language itself and around runtimes for the language. We've been talking about this for a little while, but we have support in OPA for taking policies and compiling them into a format called WebAssembly. Is there a question? There's a question in the chat. Do you have a Vim plugin? Yes, there is a Vim plugin. If you go to the website, the Vim plugin is not as powerful as it could be. It doesn't have that interactive evaluation feature, but it could. So if you go to the website, there's a link to the repo. I created that a while ago, but it gives you syntax highlighting, and you could probably build more into that if you wanted to. There's a bunch of other ones here as well that you can find links to. Cool. So what I was saying about WebAssembly was that we've had support in OPA for a little while for building or compiling OPA policies down into WebAssembly. If you're not familiar with WebAssembly, it's basically just an instruction. It's like an instruction format for virtual machines, right? So it allows you to. It's just a general purpose instruction format. It's supported by most major compiler tool chains out there. So you can compile C, C++, Rust, Go into WebAssembly. And then you can run it in all kinds of different places. So it's supported by all the major browsers like Chrome and Firefox and IE and Safari. And it's also supported by a bunch of what are called non-web embeddings. And that's what we're particularly interested in it for. So you can, there are all kinds of different applications for it. Some that I'm excited about are content delivery networks. So like Cloudflare and Fastly, for example, allow you to run WebAssembly functions, which is really interesting from a like distributed systems point of view. But there becomes this question of like, how do you protect access to those functions as they're running? And so having the ability to take OPA policies and compile them down into WASM and then run that WASM on the edge is super compelling. Similarly, like the Envoy service proxy recently added support for executing WebAssembly filters for different use cases, authorization being one of them. And so we're looking at targeting that. And then there's just a long list of other use cases. So, the way that we're looking at WebAssembly is that it provides this kind of like generic execution environment for policy enforcement, right? Instead of having to have software integrate with OPA, we can just have WebAssembly executables pushed into those environments and then enforced. And so we started working on this a little while ago. OPA has the ability to compile the Rego policies that you write into WebAssembly. And last year we added some like initial support for the entire language. We've been working since then on expanding like the built-in functions that are supported out of the box and so on. But what I'm particularly excited about is the fact that in the next release, we're going to have in 0.25, we're going to have the ability to take WebAssembly compiled policies and load them into OPA and have them executed inside of OPA. Just as an alternative evaluation engine. And that's really cool because it's going to give us a lot better performance for certain use cases. So really excited about that. I think it's gonna open up a bunch of opportunities around like library embeddings in different languages. OPA is implemented in Go today, which means that if you want to call it, you either have to embed it as a library in Go, or probably run it as a separate process and then do an RPC call into it, right? And so if you just wanted that kind of like library embedding experience, you don't have a great option today. And if you're in Java or .NET or whatever, and so this is gonna kind of open that up. And then obviously because it's compiled, it's not interpreted. There's a significant performance win there because you don't have all the overhead of the interpreter. So that's WebAssembly. Another cool thing that we've recently launched or recently added in 22 is support for what are called signed bundles, right? So bundles are the primary mechanism for distributing policies down to OPA as well as data that doesn't change too frequently. It's this kind of client-initiated pull, right? So bundles are just gzip tarballs that contain Rego files and data files. And OPA has support. You can configure it to periodically pull down bundles from remote HTTP endpoints. And so the simplest endpoint is just S3. People just put their bundles on S3 and then they configure their OPAs to download from there. And then they're done. You can do it with a different file server. You could build a custom service that serves them. It's sort of up to you. So it's designed to be as simple as possible. It's CDN compatible, so the bundles don't get re-downloaded unless they've changed. And that's all just based off of standard HTTP caching. And then they're reloaded on the fly, right? So there's that question from earlier about reloading. So that's kind of just an overview of bundles. But there's this problem or this question, which is how do you ensure end-to-end integrity of those bundles, right? How do you know that the policy decisions that are being rendered by your OPAs are based on a source that's kind of true, right? Or that hasn't been tampered with, right? How do you know that the bundle service hasn't been tampered with, or like the policies that got pushed out weren't tampered with? And so in the latest release or in the previous release, we added support for what we call signed bundles. So signed bundles are basically just regular bundles with an additional special file, signature file in them. And that signature file contains a signed JOT, which basically contains a payload that dictates what files are allowed to be included in the bundle and what the hashes of those files need to be. And so this gives us a way to basically like digitally sign the contents of a bundle and then ensure end-to-end integrity of that payload as it goes down to OPA. And so then there's the tool chain that OPA supports now to basically generate those signatures for your policies, generate those signatures inside of a bundle that you may be building, and then obviously run OPA with the right signing keys and so on so that it can verify the cryptographic signatures while it's loading the bundles into memory. Oops, is that it? Oh yeah, the last thing I wanted to mention was we also now have an IntelliJ plugin. So on the tooling side, this was a big one. This was developed by the community by a bunch of different users. It's available now. So if you go to the marketplace for JetBrains and you just search for OPA, you'll find it. If you have bugs or features, you can file them on the GitHub repo. It's got parity, feature parity with the VS Code extension as well. So it gives you syntax highlighting, that kind of interactive evaluation capability that I showed, as well as the ability to test, format, and everything. So that's all I got today. Thank you very much. If you want to get started, check out the website. There's a Slack org. Please join that. And I will also shout out our Styra Academy. It's a free online course that's available for OPA and Rego. So if you want to learn how to use OPA or how to write Rego from the people that made it, go check that out. It's got over 30 lessons on it that have like a video overview and explanation of different topics. And that's led by Tim Hinrichs, who's the CTO and co-founder of Styra, co-creator of OPA. And then it's got quizzes, so you can actually test out what you learned at the end of each module. So highly recommend that if you're getting started. So I think that's it. Thank you.
Yeah, big thanks, Torin. Lots of good information there. Hope everybody really enjoyed that. If you have any additional questions, feel free to keep them coming in the Q&A section or in the chat itself. Or always you can reach out to us through the various communication channels for the meetup. And Torin, I think he also included his GitHub, Slack, and Twitter handles as well. So yeah, thanks again, Torin. And with that, we'll wrap up kind of the formal part of this and get into kind of the closing remarks and stuff. So as always, we're kind of towards the end of the year, and this is our last kind of planned speaker event. We do have some thoughts around a virtual social event for next month-ish, somewhere between November and December. We'll get some more details there. If you have any thoughts around that, please reach out and let us know. You know, whether just a big group hangout on Zoom or what. I think we do want to try to reach out to all the folks that came and talked at the meetups throughout the year and get them to come back, which we've had a lot kind of join today as well. So that's awesome to see some of the other faces here. If you have any topics, things that you are excited about, things that you want to hear about, beginner, intermediate, advanced, doesn't matter. As always, please reach out to us. Even though we don't have any more speakers to schedule for the rest of the year, we want to go ahead and, you know, have a queue of things and start the coordination to get people set up for next year. So please reach out. Again, Slack, email, the Meetup page, the GitHub repo, whatever way you want to reach out and let us know what do you want to hear about, what's important to you. And we definitely, you know, love people from the community to come in and speak. So don't be afraid. We'll help you get your work with your presentation or whatever needs to be done. So that being said, thanks to Sales Law for sponsoring the Zoom webinar today. Big help there with that. And I'll turn over to Alex. Yeah, if there's anything left to do at this point, huh?
No, I think we're covered. Like Joe said, if there's anything you can think of that you think we could do to improve the meetup, this stuff doesn't work without the community. We're here to please you. Reach out to us, let us know. And with that, I'll go ahead and we'll end the official portion of the meetup. And I'll stop the recording. Thanks, everybody.
Yep. And just for those that aren't aware,